That started. We'll watch this video. Alright, so there's this cabinet. Alright, so we have this cabinet. Bunch of sticky notes. No. We're going to start putting these sticky notes on this cabinet. Take a moment. We are going to try to figure out how many sticky notes it will take to cover this entire filing cabinet. So right now he's working on the back, but that also means covering the top, covering the front, covering the sides. The only side of the cabinet we are not covering is the bottom. We want to figure out how many sticky notes it will take to cover that whole thing. I can put it up there, might give you a better area. Oh. That might give you a better look at the cabinet. So, your job is you need to make an assumption. You need to make an estimation, a guess. So you need to guess how many sticky notes would be too little, how many sticky notes would be just enough, and then how many sticky notes will be too much to cover your cabinet. So going to that back part, just to give you a little bit of an idea, he ends right here with 48, I think, sticky notes. Yeah, 48 sticky notes. So that sticky note right there is 48. That's just for the back. Once again, we're covering all of the sides, including the top. So make an estimation what's too little, what's too much, and what's just enough. I will not be taking bets, but I want to hear your estimation. Write it down. All right. So, what were some of our guesses we had? What were some of our estimations for your official guesses? 2,000? Okay, Colton?
1,403.
1,403? 1,332? 600? A little bone. Nice. Okay. So we have quite a few. Most of them typically between the 1,000 to 2,000 range, somewhere in that area. Good? Okay. Now, if we actually were to calculate this, what are some pieces of information we would actually need to know in order to be able to figure out how many sticky notes are actually going to have to take? Okay, we want to know the height of the cabinet. How tall is it? The width of the cabinet. So how far across does the cabinet go? Good. Okay. Anything else? The size of the sticky notes? Good. So the height and the width will give us the size of the front of the cabinet, but if we need to know those other sides of the cabinet, we need to know how far back the cabinet goes, so we can call that our depth of the cabinet. Okay. Anything else you can think of? We have height, width, depth, size of sticky notes. The top. So if you think about the top, wow, I really misspelled height. Height. Height, is that height? Okay. The more you look at it, the less you think. So the top would be the depth and the width. of the cabinet, because you think about it across and how deep it goes. So with the depth and the width, that would still give us the measurements of the top. So good. So this actually should be enough for us to calculate everything that we should be able to, or in order to figure out how many sticky notes it is. So for our measurement of our cabinets, we have a height of 72 inches. We have a width of 36 inches. And then we have a depth of our cabinet of 18 inches. So 72, 36, 18 for your height, width, and depth. Depth. Yes, depth. So those are our measurements for our cabinet. And then our sticky note. Good question, Cole. If you look on the back of the little wrapper thing, for at least these sticky notes, they are 3 by 3, so 3 inches by 3 inches. So we had our height, width, and depth, and then inside of our sticky notes is a 3 by 3 per inches. Now, once again, not every sticky note is the same, because if I pull up these ones up here, they're not squares like those ones are. They're probably 2 by 3, but for at least the ones they're using. Yeah. So we have all of these measurements that we asked for. This should be enough for us to calculate. So we're going to try to calculate how many sticky notes are going to cover the entire cabinet. Now, to help us get started, what are some things we might be looking for? What are some information that we might need to try to solve for? Height times width, what would that give you? The what? The area of the front of the cabinet. If we think about our cabinet, now I'm not an artist, so bear with me. So we have our cabinet, our little line down the middle, and then there's our little handles. We know our width across our cabinet is 36, our height of our cabinet is 72, and then our depth of our cabinet, how deep it goes, is 18 inches. So those are our measurements we had. Our sticky notes, if you think about them, are 3 by 3. 3 by 3. Now, Amanda, you said you want to take the 72 by the 36, or 72 times 36, and that will give us the area of the front. So if we remember, area of a poly, or area of a parallelogram, which is a rectangle counts as a parallelogram, is always going to be base times height. I'll put those in lowercase letters, actually. So it's base times height. And so our base is 36, our height is 72, so that will give us the area of the front. And that's some number that we'll find in a moment. So that will give us the area of the front. But once again, we're looking for 5 sides. We also want to find the area of my left side, the area of my right side, the area of the top of my cabinet. The area of the front and the back are the same. Okay. So see if you can find the area of all 5 of those sides, calculate them together, and then see how many sticky notes, depending on the area of the sticky notes, how many sticky notes it will take to cover that area. So take a moment, see if you can calculate those 5 areas. Okay, so if we were to do these measurements, we had to figure out, okay, what is the front and the back? What is the measurement of the front and the back of my cabinet? Which for the front and the back, we saw it was, I'm sorry, actually the front and back is what we did up here. It was at 36 by the 72, the base times the height, 36 by 72. And we found that to be 2,592.
Wait, what?
So that was, so it's 36 by 72, that gives you the measurement of the front, and 36 by 72 is the measurement of the back as well, right? So that's our front and back. Our sides, we have 2 sides of our cabinet. Our size of our cabinet was a depth of 18 by a height of 72, so that was 18 times 72, which that came out to be 1,296. Okay. Once again, these are all in inches squared, because we're talking about inches. Okay. So those are my two sides of my cabinet. And then the last piece we were missing was our top of our cabinet. So the top of our cabinet was equal to 18 by 36. So 18 inches by 36 inches, and that gave us 648 inches squared. So this was our measurement of our front, our measurement of a side, and our measurement of the top. But we have a front and a back, and we have two sides. So we need to take these two numbers and we need to multiply by 2 in order to get our total surface area. So 259 times 2, that gives us 5,418. 5,484. No, 5,184. One. So that was our front and back together. Our two sides multiplied by 2. If we look at the area of both of those sides together, that was 2,592. The volume of, or the area of just a single track. And then we had our 648. We don't need to multiply that by 2 because it's just our top. We're not worrying about the size of the bottom. And so we can take 5,184 plus 2,592 plus 648. All of those two added together. Wait, I need my 648 in there too. All of these added together gave us 8,424 inches squared. So all 5 sides together was that amount of area. So we have 8,424 sticky notes in total. Right?
No.
No? What's wrong? Good. So our sticky notes are not just an inch by an inch. They're 3 by 3, which means they're 9 inches squared a piece, so we have to take our 8,424 divided by 9. And that final solution should be 936 sticky notes in total. And that should be your final. Are we okay with this? 936. So once again, you're looking for the area of each of those different possible sides, calculating on them all together with determining on how many we have. So we have 2 fronts and backs, we have 2 sides, and we only have 1 top. Add all that together, divide that by our area of sticky notes, and we should get 936. So let's actually check to see if this is true. Did it actually take 936 sticky notes? There you go. Person has a lot of time. I think they have. So 288 was just the back. 432 was one side. Oh, we have to worry about these. How do you deal with that? I don't know. We'll just go. That's fine. 719 was the front altogether. 863 was all the 4 sides together. So we just need to do the top. 30, 1, close, 934, 935. Wait a moment, we had 936. What messed up?
The
You didn't put them all
handle
on.
thing.
So we had the handles.
There's space in between some.
If we look, there's like a little gap right here. Not a perfect amount of sticky notes covered the whole thing. Sometimes the sticky notes, they might be covering each other a little bit. And so overall, there's a little bit of error here or there that might have happened. And so we were very, very close, and we had a very accurate answer of 936. But due to human error and due to just some things that we can't really calculate, we were off by sticky notes. Yeah, but I would consider it correct with our area. So good job. So that's what we're going to be talking about this week. We're talking about surface area. Today we're dealing with prisms. So a prism is any sort of three-dimensional figure that has a shape for the top, a shape for the bottom, and then has sides connecting those corresponding sides on your two shapes. But your shape from the top and your shape from the bottom always have to be the same shape. If you have a rectangle on top, it has to have the same rectangle on the bottom. If you have a square, it needs to be the same square. If it's a circle, it needs to be the same circle. A cylinder is still considered a prism, even though it doesn't have to have a size. So those are our prisms. We're going to talk about how to find the surface area of prisms today. So when we talk about surface area, there's two types of surface areas we actually consider. The first one is called total surface area. So total surface area is what you think of when you talk about surface area. It's all of the sides. I'm looking at all of these sides. I'm going to figure out how much it would take to cover all of these sides. That's my total surface area. So it's the sum of both of your bases and the sum of all of your sides together. If you find one base, because we know the bases of prisms have to be the same, you know it's going to be the same as your other one. Not always are your sides always the same though. Like in that last example, we had the front of our cabinet was different from the side of our cabinet. And now it's different from like the top of our cabinet. And so not all of your sides are going to be the same. So sometimes we might have to do a couple different measurements, but typically you're going to get at least two that are going to be the same and some other measurements like that. So that's our total surface area. So if I wanted to paint everything in this room, I would look for the total surface area. But not always are we painting everything in the room. Typically we're just like painting the walls. And so that's our other type of surface area. If we're just painting the walls or something, that's our lateral surface area. We don't care about the floor. We don't care about the ceiling. You're just looking for the sum of all the sides. So we have two types of surface areas we just need to keep track of. I typically denote total surface area as TSA, like your airport security, and then your lateral surface area, which is the LSA. But that's what I write when I write shorthanded, but if I write that on the board, just to let you know, you don't have to follow that. So oftentimes we'll be asked two things. You'll be asked what's the total surface area and what's the lateral surface area. But the thing is, if you calculate the total surface area, you already know all the sides, and so you can add those together. So typically, total surface area, if you already have that, it's easy to find the lateral surface area because you're just adding up less things. You just don't want to work out things. Are we okay with this so far? Of surface area? And we've probably been familiar with surface area in the past. We've probably done it a little bit in 8th grade or 7th grade mathematics as well. But we're going to worry about just calculating more and looking at different types of shapes that we can do with. So we probably have enough time to get through both of these two, and that's where we'll stop for today. It's just with these two, and then we'll pick up the rest. So surface area. Once again, a prism can be multiple types of shapes. It depends on what your bases are. So you might have a rectangular prism, like our cabinet. You might have a triangular prism, like the one we see on the board. You might have a pentagonal prism that's made of a pentagon. You might have a circular prism, which is just a cylinder. So there's multiple types of prisms that you get. It's really just dependent on what the base is. So depending on what those shapes are, we have to change what our area formulas are. And that's why it's helpful to have that reference sheet. You might need to figure out what's the area of a triangle, what's the area of a circle, what's the area of a square, or what's the area of like a rectangle. So we can use those area formulas to help us out. So we want to find both the total surface area and the lateral surface area for both these shapes. So we'll look at our rectangular prism first. Now, if we want to find the total surface area, we just need to work like that cabinet and start finding all the area of each of those sides. So that means I need a front and a back. I need a side and a side. I need a top and a bottom. And so we'll have to do a couple multiplications. So once again, base times height, or base times height is your surface area of a parallelogram or surface area of a rectangle. And so we can do 3 times 3 will give you your area of our front and our back. So 3, that's 9 feet squared. If I want the area of my two sides, it's going to be my height times my depth, which is 3 times 5, which is 15 feet squared. That's both my sides of my rectangle. And then my top and my bottom is a 3 by 5, again, which is another 15. Once again, each of these measurements, though, it's not for both the top and the bottom. It's a top or a bottom. So if I want to calculate all of this stuff together, I'm going to need to double these. So if I double that, that gives me 18 feet squared. If I double this, that gives me 30 feet squared for both my sides. And then for both my top and my bottom, that's another 30 feet squared. So I have all these measurements. Are we okay with this so far? And then if I want all my total surface area of everything, I just need to add all these together. addition problem, and that gives me 78 feet squared is my total surface area. Yes. So again, it's both my sides, my fronts, and my tops. But once again, we're not always looking for the total surface area. Sometimes we just want those sides. So rather than adding all this up, the only thing I'm dropping off is I'm not caring about that top and the bottom. And so I'm just going to add these two together. And together that gives me 48 feet squared for my lateral surface area.
Why? Mine's good.
So lateral surface area is just our sides. It's like if you have a soup can and you just want the sides of the can, you don't care about the top of the can or the bottom of the can, that's what we're looking for. So that means we don't have to worry about the top, we don't have to worry about the bottom, so we're just going to drop off that last measurement we had for the total surface area, and then we just calculate our sides. And then we'll look at this triangular prism next. So, triangular prism, same idea, except our two bases, once again, a base of the prism isn't always on top. For example, this one doesn't really have a top to it, it has like that slanted side. But our basis of our prism is always going to be that defining shape. So in this case, that defining shape of your prism is the triangle. That's what makes it is triangular prism. And so those are going to be our bases. But let's find our total surface area, and then we'll worry about the lateral surface area. So for total surface area, we need to find all those sides. So first, I need to find my area of my triangle. We'll start with that. And if I think, I'll look at that reference guide, area of a triangle is 1/2 base times height. Well, luckily I have my base, I have my height. It doesn't tell us, but we can assume this is a right triangle, so we'll assume that's correct. And then we can figure out this. So area of my triangle part is 1/2 3 times 4, or 1/2 4 times 3, I'm sorry, if you wanted to put base times height. And that gives you 6 meters squared. So that is just one triangle.
Why is there 3?
3 is the height of my triangle.
Why is there 1 over 3?
Oh, I'm sorry, that should be 2. Thank you, Morgan.
I was going to say. Wait, so this is just for the front and back?
This is just the measurement of essentially one of my fronts or my back. If I wanted to get both of them, I just have to double it like we did before. Another thing we might notice with this triangular prism is because my triangle has different side lengths, my other sides are going to be different as well. Like this back side is going to be different height, or different length of this side, which is going to be different length of the slanted side. So I'm going to need to use some different measurements. So for this back side, it's a 3 by 7. So 3 times 7 gives me 21 meters squared. This bottom part is a 4 by 7. So 4 times 7 gives me 28 meters squared. And then I have this top slant. I don't have the measurement of that length right there on the top. What do we have to do?
Pythagorean theorem.
Pythagorean theorem. We have a right triangle, we can find our hypotenuse. So that's our C in a sense. So if we do 3 squared plus 4 squared equals C squared, we already set that up. You could work through this. Another thing you might notice is we've seen this one before. This is one of our Pythagorean triples. This is something that keeps showing up. So 3, 4, 5 is our Pythagorean triple. So that makes C equal to 5. And once again, if you don't recognize that right away, you can still work through Pythagorean theorem and you can still get the right answer. But if you do recognize it's Pythagorean triple, use it. So that gives us a 5 times 7 would be that sort of top slant cover that we have. And that's 35 meters squared. Now the only side we have 2 of, the only side that's doubled is our triangle. We have only one top, only one sort of back, and only one bottom. So we don't have to worry about doubling the rest. But if we double this triangle part, that gives us 12 meters squared for that piece. And then if we want this whole thing, we're going to calculate the total surface area, our TSA. That's going to be our 12 plus 21 plus 28 plus 35, which that total surface area should be 96. That's all of our surface area together. And then lastly, if we just wanted our lateral surface area, our LSA, the only thing we're dropping off are those two bases, which are based in this case are the triangles, because it's a triangular prism. And so
Well, how do you know that though?
it's because that's the sort of the defining shape that separates it. So a prism doesn't always have to be standing on its bases, standing upright. With a rectangular prism, you can't really tell unless they denote it. With a rectangular prism, you just assume this is the top, this is the bottom, and those are your bases, because all your sides are rectangles. But for any other prism, it's really the side that isn't a rectangle. It's going to be your base. So it's our two triangles, and so if we were to add up all those together without our triangles, it should just be 84 meters squared, and that's our lateral. Good question, Mark. And this is where we're going to stop today. We'll pick the rest up tomorrow. Remember, tomorrow you have a 2-hour delay as well.
Yeah. Didn't we cancel?